you want to say something?
No.
Okay, so hello everyone. My name is Paulo and I'm from Reddit. I'm, as you can see, a software engineer and I work in the Vert.x open source project. And I will just try to make a small talk. I will not go too long because it's already late. I'm going to do a small introduction to what Vert.x is. And what we just released last Monday, we just released version 3.3, where we introduced a couple of new components to build the microservices. And I will just do a quick demonstration on the new features. So, as I said, I'm going to keep it short. I will just go in bullet points what Vert.x is. So Vert.x is a toolkit for building reactive applications in JVM. So we don't focus on microservices per se. Microservice is just something you can also build with Vert.x. We are a general purpose application framework. We consider ourselves as like a Swiss Army knife for building modern scalable web applications. We are event driven. We are non-blocking, like all the trendy stuff now. And we are polyglot, so it's just because we run on JVM doesn't mean that you need to use Java. Basically, we support Java, JavaScript, Groovy, Ruby, Ceylon, and unofficially Scala, Python, and a couple more which I don't remember out of my head. And on top of all this stuff, if it's not enough already, we are lightweight and fast. So we are quite good benchmark on, for example, Tech and Power. So, and finally, it's fun to work with. That's my opinion. So I said in the beginning that Vert.x is reactive, and if everyone here knows what a reactive manifesto is. So the reactive manifesto was something written a couple of years ago by some guys who later founded this company that created Akka, and now they are called Lightbend, if I'm not mistaken.
Yeah. Yep.
And basically what they say is that, well, if you want to make your application scalable, well, you should use a message-driven architecture because that increases that gives you responsiveness. So your application will not be waiting. And if you do this, if you use the message-driven architecture, then you'll be resilient because if one component dies, it doesn't mean that the whole application is down because the other component can receive a message and process it. And because you're doing message-driven architecture can be elastic, it means that if one node is not enough to process all the load, you deploy more nodes, and overall, it all means that you are responsible. So, in a nutshell, that's the reactive manifesto. And if this is a bit complicated, just think of Excel. If you put one value in one cell of Excel and you make a formula there, once you change the value here, it changes there. So basically, Excel is reactive. So I learned last week or so when I was at a GoTo conference, someone was doing a very nice presentation on functional programming on Excel. So it was quite interesting and actually it's true. And so let me explain now that you have like basics, how does Vert.x work. So I can define Vert.x because it's so small library. It's so small that I can put it in one slide and explain it to you guys. So as I said, we are polyglot, so you can use any language you want that runs on JVM, but that's not a big deal. Lots of frameworks can do the same. Second, we have the concept of vertical. So what's a vertical? A vertical is what, if you guys know Akka and all that kind of frameworks, is what they call actors. However, actors are quite strict with their content, and verticals are a bit more loose. So it's not, we don't enforce you to be immutable. So you can have a bit of state. It's fine, and it's kind of your deployment unit. So now that we're talking about microservices, your microservice will be probably started from a vertical. It's like your main application. And what is vertical in the framework? Vertical is just a Java interface. It has two methods: start, stop. That's it. So And we have an abstract implementation where you only need to implement the start. We will do the stop for you because, well, if most people don't need to stop, we just shut down the JVM and you're done. Because we try to follow what you guys saw in the previous presentation of fail fast. If something crashes, we just stop, kill JVM, that's it. So, because we are reactive, it means that we are message-driven. We have a message-driven architecture. So we have events, and events is anything that can go on the framework. And an event in our case can be a file, a HTTP request, a JSON message, a binary blob, anything you can model as a Java object in the JVM, so to say. So there are events, and these events are handled by event loops. And notice here that I have the plural. Like if you guys come from Node.js, you say, oh, we have the event loop. And this is not a mistake, we have event loops. And the reason is that we noticed that one of the downsides of Node.js is that it's very interesting. You have one single event loop, so you don't have the threading issues and all of those things. But if you need to, if you really look at the usage of your resources, of your machine resources, say that you have like 8-core CPU, you'll notice that you only use 1 core. And then to use the full capacity of your machine on Node.js, you need to do fork of the process as many times as CPUs you have, and then you see that you can use the total capacity of a machine. In Vert.x, we decided to, when the application starts, it enumerates how many CPUs you have, and it will have one event loop per CPU core. So it will give you automatically the full capacity of your machine. Important thing to know is that because each event loop is one thread, once an event comes here and it's being processed, once the message comes back to the event loop, it will go to the same event loop where it started. And the reason is that once we do this for you, you will never need to have to worry about thread safety, because even though you have many event loops going on, messages that start here will always be handled here. So there's no need to do synchronized blocks in your code. So we have the event loops, and the only thing you need to implement on your vertical are handlers. And because we are on Java 8, handler is a very simple concept. It's a functional interface. Basically, it's any interface with a single method, and the method will receive one event of the type you guys decide. Once we look at Node.js and all these technologies, okay, that's interesting, but we can do it better, because it's very nice to have a simple programming model on one machine, but I want to have it across several machines. So what Vert.x also gives you is the event bus. And the event bus is an abstraction for our message-driven architecture that allows us to scale across multiple JVMs on the same host, or even across different machines. And event bus are just SPIs, and we provide out of the box. We have 3-4 implementations. We have implementation based on Hazelcast, which is kind of our standard because it's the easiest one. By default, we'll try to use your multicast network. So if you have a normal network at your office, probably will have multicast enabled by default. So it means that if you run an application on your machine and your colleague's laptop, they can form a cluster without you guys having to do anything. Of course, if you want more control or your network doesn't support multicast, you can tweak Hazelcast, or if you don't like Hazelcast, we have support for Zookeeper, JGroups because we are Red Hat, so they pay our salary, so we have to also do that. And having that implemented, we have built a tiny library that allows you to make distributed applications. And so as you guys can see, like in 680 kilobytes of code, you get all of this. So this is Vert.x, so to say. So what's about with Vert.x and microservices? So in the last couple of months, I think last 3 months, we've been working on version 3.3. And in this 3.3, we were adding a couple of new features because microservices are getting more and more popular. And although you could already do microservices, because if you go back, like, well, you just deploy a couple of verticals on 2 or 3 machines because they are connected to the event bus. And the event bus is very simple. It just sends JSON messages, and you can address any handler on the event bus with a simple string, and it's just to us an opaque string. You guys give the name one. So if you want to make like a kind of cluster with the microservices, you just deploy, I don't know, 20 verticals, and they call vertical 1, 2, 3, 4, 5, 6, 7, 20, and then you send a message. One send to vertical 1, and vertical 1 says, okay, here I've done something, send to vertical 2 for post-processing, and so forth and so forth. And this works fine if all your components are vertex, because the event bus will make sure that everything gets discovered. But if you need to integrate with all the components, of course there's a little bit of more work. So what we added, what we try to do is, like, we don't try to reinvent the wheel, and the reason that we do this is because our team is small, so we don't have the capacity and the budgets of other big projects to define new tools and so on. So we'll try to reuse, to find out what people are using out there, and we make what we call bridges. And bridges are just small glue libraries that we can call APIs from Vert.x themselves. So everything goes on top, of course, with what I just said. And we implemented a discovery service, and this discovery service is again SPI. It's not an implementation. We then implement a couple of implementations of the SPI, and we have implemented a circuit breaker. I'll go into details what those things are. So the discovery service. It's SPI, so you can bring your own implementation if you don't like the things we already implemented or that the community has implemented for us. And we have implementation for Kubernetes. So if you have a Kubernetes cluster, so if you guys follow the previous talk, you can use Vert.x 3.3 with our discovery service, and it will have some nice gorgeous and interfaces to see all the pods and so on.
Question? What do you mean with SPI?
SPI is a that's a good service
programming interface.
Programming interface. Yeah, service programming interface. So basically, it's just we have the core Vert.x discovery service is just a Java interface, and then we implemented a couple of implementations on this interface. So we have implementation for Kubernetes. So if you need to, what does this give to you is that in your code you just say create new service interface, a service discovery interface, and discover service with this name. And now you don't know anything about the details of the implementation. And the funny thing of SPIs is that you can just replace the jar file at runtime. You replace the jar file of your implementation with Kubernetes, Docker links, console, or Redis, and your code didn't change. You don't need to recompile. You are ready to go. You just swap a jar and run.
Like auto-deployable.
It's not auto-deployable. You need to stop and start.
Okay.
But the core library as a feature, I cannot go in all details, but on the core library we have a concept of auto deployment. So if you are doing stuff with web application, so you are editing your HTML on the resources folder on your Maven project, for example, on your IDE, not specific Maven. Every time you save a file, we have this watchdog on the library that says, okay, that file changed, I kill myself on start again.
Okay.
And because the library is so small, we can start in milliseconds. We don't take even seconds, we start in milliseconds, so you don't even see it. It's like Node.js,
okay,
like all of those front-end development. So, as I said, we have all these implementations for the discovery service. And then we have the circuit breaker. The circuit breaker pattern is nothing that we invented. This is from Martin Fowler. blog. I shamefully stole it and I didn't get the credits. Shame on me. So basically, this is the concept. So basically, it's a wrapper before you're doing a request to external service. And what it gives you is some safety. So say that you have your microservice A that needs to talk to microservice B. So once you make a call, once you need to make a call to B, you wrap your call in the circuit breaker, and the circuit breaker will check, okay, is the service alive? If it's alive, call it, get response, return. Is the service down, so it makes a request, it gives a timeout. It switches to the state open. This is basically from the electricity, from the switch code. So it switches to state open, and then in the state open, we have options that you can do, either try again or have a fallback solution. And if a couple of times, if you try again, try again, it goes to the alpha open. If it passes, okay, it's closed, so back to normal, everything was fine. Otherwise, it's just okay, it's totally open. There's no way everything will ever come back from service B. So we'll keep returning the fallback solution. And I will just quickly go on the demo for this. And for this, I need to sit and show the code. One thing I need to say is that the Vert.x is unopinionated, and by this it means that we don't have magic annotation. So if you want to do something, you really need to write the code for it. And the reason we decided to go this way is that if you write the code yourself, then you know how everything works. So you are aware of the performance impacts and all the penalties that can be introduced. And we don't have any bytecode generation things going on the back. So Vert.x application can run on a Raspberry Pi without any problems. And as a matter of fact, I did a demo last time which didn't went that well, but this Raspberry Pi I showcased the C10K problem running on a Pi, implemented in Vert.x. So the Pi was handling 10,000 WebSockets connections and 10,000 server and client. So in total, the Pi was handling 20,000 WebSocket connections, and they were sending messages to each other. So you can imagine that we try to keep our memory to the minimum and the most throughput. So I'll go to the demo part now. I need to swap to this, and I need to move this. It's funny, it's on the right. I need to mouse, where is mouse? I need to swap this. Where's the mouse again? There it is. So what I'm going to show here is basically what was described on the meetup. Basically, I have 4 web services. I call them A, B, C, D, and they also allow in different languages. And service A will do all the circuit breaker and discovery stuff for you. So I will start first with B, C, and D are all the same. It's just the language changes. So I will show you how complex it is to create a Vert.x application. So as I said, this is a bare bones Vert.x application. So as I said, we have this abstract vertical where you only need to implement the start method, and router is a helper class that we provide that allows you to make HTTP request routing to paths and handling to functional interfaces. And then pretty much like modern web frameworks, we don't use servlets or anything. So basically you say, router, when there's a request to slash, this is my handler, so this is my HTTP context. I get the parameter name, and then I say from the context, get me the response object, and put HTTP header, content type, JSON, and end up with key is B and the value is hola and the name and pretty Jason. And then I say, because I say there's no magic, you need to do everything, I create an HTTP server myself, and I say every request to this HTTP server will go to my router accept method, which then will delegate to this. And I say listen to the configuration on some configuration get port. So if I go on B, C, C is pretty much the same, but okay, the other one is Spanish, this one is in Portuguese, because, well, I'm Portuguese. And D is Aloha, just because. So these are like very basic. And then on vertical A, okay, you guys might think, yeah, you're showing on this one, but you're not showing how you bootstrap the whole thing, so I'll show you the main vertical. So I'm doing here some bootstrapping, which is saying, well, every time a vertical starts, I need to, because we are not, if you were all on the same cluster, then this wouldn't be needed, because the Hazelcast will discover all the other nodes, and I will be done. But because I'm assuming that all my clusters running on different machines, I need to bootstrap my service discovery. So as you guys see, service discovery, I say, well, create me a new instance, and then I need to publish this service, and this is the name of my service. If this is a bit complex, once I show you it might be a bit more clear. So what's happening is it's publishing into the directory a new service with the name B, and it will collect all information from here. And when it stops, it says unpublished from the service discovery, because, okay, remove it because, well, nothing is listening there. So I'm not going to start here Kubernetes or anything, I will just run everything locally. So the simplest service discovery implementation is Redis. So I'll quickly start Redis server, so sudo. I have a Docker image of Redis, so I don't care about its state, I want it to die in the game anyway. So boom, and Redis server running. And of course, this would be interesting if you are probably deploying on Heroku, where they don't allow communication between nodes, but they have their Redis server. So in that case, you just need to know where their Redis is, and you're done. So I have the Redis server. So now I will go on CD. Do I have to go do? I probably need to do everything. So I'll install. This will build the old stuff, so it has a couple of.
Paulo is building anyway. Where do you need the Redis for? Because it's a key value store.
Yeah, it's only to keep the location of all the services.
Okay, check.
So
I didn't get it.
So the service discovery will then talk to I'm setting up. So the part I missed was that in my form I need to say this is very shady because I use Maven by putting all the dependencies here. So basically I say all my dependencies for my project is a Vert.x core, Vert.x web, which gives me the router object, Vert.x circuit breaker because I will show you, and the service discovery, and then on the forms, one of these forms I should have the dependency on the Redis, or was that there? I'm a bit confused.
There's an intermediate level, right?
Yeah. Let me see if it's getting. Let me see. It should be ready here now. Redis is being pulled, so that's fine. So the thing is like this Maven project was made by someone else. I'm not really about the details, but there should be two of these. One.
Because there's one XML, one level lower than the top level.
There's a top level, and then I should have, oh here. Yeah, there is. So they all inherit from this one. And this one I say, okay, on top of the service discovery, I want the Redis implementation. So if I want other ones, I will just change it here.
Yeah, so it's SPI.
So add Redis running. So I will go to, let's do aggregation first. Doesn't matter. Okay. You can have the commands. So basically, I will do this. And what it does is, well, I'm using the Maven shade. That means that all my dependencies end up in one single jar file. So my single jar file contains everything I need to run. So this will be around 6-7 megabytes with all the transient dependencies. So to run my application, I need to do java -jar a snapshot of a jar, and then I specify the config, because you guys saw that config get the port number, and the config is just a JSON file where I say, well, A listens on 8080, B on 881, C 882, D 883. So that's just to add that. Otherwise, you don't even need to add it. So I start A, it says it deployed, and it's okay. So I go here and I do aggregation D based, and of course here needs to be B. It's deployed. So you guys see that the Vert.x application starts quite fast, so I do done. And let's see, aggregation D. Okay. So if as they say, if the daemon gods are with me, I should be able to click here and go to local host 8080. Of course. And that's because I quickly amended them and did not make this properly next stored. Yay. Control plus. So basically, I have no internet, so my CSS is dead. Doesn't matter. It's still can still get the idea. So basically, the idea is that, well, it's if I put your name and invoke, A will call B, C, and D and aggregate the results and return. So if I do this, oh crap, the jQuery is not there. That's not nice.
That's very resilient.
No, without internet there's no JavaScript. There's no jQuery. Oh, that was a mistake. Bootstrap CDN.
Do you want Wi-Fi?
Yeah.
Yeah, I was already.
Wi-Fi. Select network. There's an open one. Can I just use the open one?
Called B.Argus.
B.Argus. Connect. Authentication. Get internet access. Yes. Welcome. You are now guests. Great. So let's try again then. There they are. Okay. Okay, so if I invoke and if now again the gods are with me. Oh, okay, there you go. The A will call, we get the result from A, which is local, so it's always that will always work. B, C and Aloha. And the interesting thing is that I have here quickly built a small page where you can see the state of my services. So although I'm calling A, B, and C, I don't know where they are. What happens is that the service discovery will ask for Redis, where we just store this information. And Redis has like this information. What's the host? What's the endpoint? What's the port? Does it require SSL? What's the root path? And so on and so on. And then I have the same thing for the circuit breaker. I see that they are all closed, so everything is green, so that's fine. And now I'm going to do is I'm going to split screen this because I want to put something here. So I have all services here. Oh, that's not the kind of split screen because I will need to go to IntelliJ, so split screen this. So let's see if I get it right. So this is Redis. This was A, B, C, D. So if I would go here, say C, and I say I kill it, so Control C, no. What happens is that on the circuit breakers now, if I would, oh, I should put it. So localhost 8080. If I go here. Stuff. You see that A gets the response, B gets the write response, C gets service not available. It's the fallback response, and D, oh, okay. So, and then I keep track of the failure. So if I do this, you know, oh, it's failing too long, so it's always failing. And if you wait a bit, we have some timeouts and okay, so control like a while, and it should. I think after 10, I think I configured for 10 seconds it will change back to close. So, or 30 seconds, I'm not too sure. So if we go to the code, so what's a circuit breaker then? How do you make a circuit breaker? So, circuit breaker in Vert.x is just object that you create, like circuit breaker to create, and you give it a name, and this name will then be resolved by the service discovery. And these are the options. I said that I set a max of 2 failures before I close it, I open it, and I have a timeout of 2 seconds between the alpha open and closed. And if I need to reset it, I need to wait 5 seconds. And I have fallback. I want to have a fallback implementation. So I create my circuit breakers here, and when I do the real calling, which is here the calling, so I get the param name. I use futures because okay, we are synchronous and using this message-driven architecture. So I need to everything is this. So say get B and invoke. And invoke is just here because it would be repetitive. It would repetitively call the same stuff. What it's doing is given the circuit breaker implementation instance, execute with a fallback. So first it tries the normal way. So from the service discovery, I have a HTTP client that was given to me by the service discovery, and I say make a GET request with that path, and if when the response body returns, I can I parse the JSON and do so. I say I'm done. And if it fails, then I just say send the default failure message, which is delegated here like no service available fallback. So in a nutshell, that's this. So if I would now go back, if I go here again, I say okay, let's start again the C, deploy it again. So if I would, no, wrong page. If I would go back, and I would book it again, I start getting again the C. So basically, in a couple of lines of code, you will get like all this resilience and all the things you need for making interesting microservice applications. Of course, the circuit breaker API is not just an aggregation; it can also be used as a pipeline. So basically, if I stop this and I start the odd example, it's pretty much it's pretty similar. But instead of A calling B, C, and D and aggregate results on return, it will say A calls B, B calls C, and C calls D. And in the end, you get exactly the same output. But it's just that you are chaining calls, pretty much like you would be doing on a synchronous way of programming. So once you get the response from the database request, you do something, then you call again to the database to do a second query, and you get the response, then you call it again, instead of just doing. So if I would go like that, CD, first line, D, D.
I think you need to go into C again.
Oh, yeah. Yeah, that's it. Sample D. Yeah, so this is pretty much the same. The thing is that, well, the orchestration now it's spread across all the services, so they're all the same. So basically, when they all have their own service discovery and their circuit breaker for calling the next one. So again, HTTP router instance, get a reference to the discovery service, create a circuit breaker called A, some default configurations, and then this is just to serve this HTML. If we want to show on the other services. So when I do a get A, we'll end up doing our hello call. And hello, this one is simply just get client, and get client is just from our service discovery, get the client with the name B, and you get the HTTP client. And once we have the client, we can then invoke a reply. So we just okay. I executed everything read on the circuit breaker. So my client will talk to the B server and do the request, and then pass the result back to my callee, and then you get everything in a nice encoded text. So in the end, let me just close this one. in the end it gives you the same result. And it's just to show you that the circuit breaker API is not just strict for aggregation. In these examples, because I wanted to keep it short and I will not go more into details on the code, I always stop with HTTP. However, our discovery service will allow you to define several kind of responses. We have HTTP, we can have even event bus addresses. So say that you have a cluster, Vert.x clusters on one cloud provider, and then you have another one in another cloud provider. You can use the discovery service to both clouds to discover each other and then send messages to specific addresses on their other machines. So you can mix addresses for external services like this, or you can even use it to find a specific vertical on a separate cluster. And because, as I said, it's SPI, you can always extend it and add more implementations and other features. And I will now ask if you guys have any questions, and I'm done with my presentation.